The distributive property is our topic for lesson 4. We're going to look at how do you apply the distributive property and to rewrite algebraic expressions. So we're going to take our expressions and we're going to continue to learn how to manipulate them, and this time we're going to use the distributive property to do so. All right, so Jordan buys 3 notebooks that cost $5 each. He also buys 3 packages of pens for $6 each. Number 1 says write an expression that shows the cost of 3 notebooks added to the cost of 3 packages of pens. Well, if we want to buy 3 notebooks, each one costs $5, so that would be like saying 5 times 5, 5 plus 5 plus 5, or 3 times 5. And if we want 3 packages of pens, that would be like 6 plus 6 plus 6, or 3 times 6. All right. So number 2 says write an expression that shows 3 times the cost of 1 notebook and 1 package of pens. So we want 3 times that cost. Well, that would be the cost of the notebook and the pens added together, and then we would multiply that by 3. So we'd be looking at 3 times the quantity of 5 plus 6. All right, so let's evaluate both those expressions and see what we get. So with number 1, we have 3 times 5, which is 15, plus 3 times 6, which is 18. If we add those together, that gives us $33. All right, let's look at for number 2. All right, that would be 3 times 5 plus 6, which is 11, and 3, well, it looks like a 4, like a weird 4. 3 times 11, and 3 times 11 is 33. So, as you can see, we actually get the same thing for both of those. All right, so number 4 says suppose Jordan buys 5 notebooks that cost $3 each and 5 packages of pens that cost $1 each. So he gets cheap pens. We're going to circle the expression that represent Jordan's purchase. All right, so, well, this one would be 5 times 3. So the notebooks cost 3. All right, so seems like it would work. All right, this second one here, 5 times 3 times 5 times 1. No, we want to combine those two, not multiply them. And then this one, well, 3 plus 1 is 4, and 4 times 5 is 20. Well, that's the same as 15. So this one seems to work because that gives you a total of $20. But then this one also seems to give you a total of $20. So it seems to work either way. All right. So it says, suppose Jordan buys 2 rulers that cost $1 each and 2 folders that cost $1.50 each. Circle the expression that represents Jordan's purchase. So we bought 2 rulers at $1 each, so there's $2, and 2 folders at $1.50 each, so 2 at $1.50 each, that's $3. So it's 2 plus 3, it's $5 total. So let's see which one of these gives us $5 total. Bump that up a little. All right, so 2 plus 1 is 3, plus 2 is 5, plus $1.50 is $6.50, so it's not that one. And this next one here, we've got $1 plus $1.50, so that gives me $2.50 times 2, that gives me $5. Okay, so that one's good. And then this one is 2 times 1, that's $2, and 2 times $1.50, that's $3, so that's 2 plus $3, and that one's $5 too. So those two both give us. So I can't help but notice some similarities between those. And let's keep that in mind as we move forward. The distributive property states that to multiply a sum or difference by a number, multiply each term inside the parentheses by the number outside the parentheses. So basically they're saying if you are multiplying an entire expression by a number, you can achieve the exact same result if you multiply each term inside the parentheses by the number that's being multiplied by. So for example, look at this 4 times the quantity of 6 plus 2. It's exactly the same as 4 times 6 and 4 times 2. They are exactly the same thing. All right, so I always like to think about it. It's like you see up here, it's like you're distributing that multiplier to each term, distributing it out. Okay, so one of the really cool tools we have that we can use here are called algebra tiles, and we'll use these in class. But if you take a look here, I'll show you how these algebra tiles kind of work. So it says you can model the distributive property with algebraic expressions using algebra tiles. The expression 2 times x plus 2 is modeled below. So each one of these green guys represents an x. Each one of the yellow ones represents a 1. So we're going to represent x plus 2. So here's x, and to represent it, adding 2, we just put 2 positive 1s along with it. So right there, that represents x plus 2. Remember, our expression says 2 times x plus 2. So we don't want just one of those x plus 2s, we want 2 of them. So I've got an x plus 2 here. And if we were subtracting a 1, we'd have red ones for negative. And then I want 2 of these because I have 2 times x plus 2. So there's 2 x plus 2s. All right, and then the last step is we simply take the tiles that we have and we rearrange them to create one single expression. So I take my 2 x's and I can put those two together. All right, and then I can take all 4 of my 1s and I can put those together. Just like that. And then this becomes the expression. How many x's? I have 2 x's and I have 4 positives, so that's plus 4. So as you can see, we can turn that into 2x plus 4. Okay, so in our first example here, we're going to evaluate, using the distributive property, 8 times the quantity of negative 9 plus 4. So what we're going to do is rewrite, and we are going to show how we distribute this 8. Now, obviously, since this doesn't have any variables in it, we could simply use PEMDAS, or order of operations, and solve this. But we're practicing our distributive property, so let's do that. So basically what we're doing is multiplying this 8 by each one of those terms. So it's like I'm multiplying here along each one of these lines. So we really have 8 times negative 9, and then we're adding that to 8 times 4. So these two expressions are equivalent. They are exactly the same. They have the exact same value. And then from here, we can simply simplify. Simply simplify, I like that. So 8 times negative 9, positive times negative is a negative, 72, plus 8 times 4, which is 32. And then if we add those together, we get negative 40. And that's our answer. If we used order of operations, we would get the exact same thing. Negative 9 plus 4 is negative 5. Negative 5 times 8 is negative 40. So as you can see, it works either way. So let's look at a couple more down here. So they want us to use the distributive property to rewrite each expression. So we don't even have to solve them here, okay? And we can't because there's no way to know what those variables are because they don't have equal signs. So let's rewrite. So remember, we're going to take 4 and we're going to distribute it to each term inside the parentheses. So this becomes 4 times x plus, oops, I want to put that there, making a mess of this, plus 4 times 7. And when we simplify that, that gives us 4x plus 28. So that's our simplified version, 4x plus 28. Same deal here. 6 to p and 6 to 5. So that's 6 times p minus 6 times 5. We're distributing that 6 to each term. So we get 6p minus 6 times 5, which is 30. So we end up with 6p minus 30. So 6 times the quantity p minus 5 is equivalent to 6p minus 30. It's as far as we can take it. We can't figure out what p is because we don't have an equal sign here. All right, number 4. So again, distribute that negative 2 to each term. Negative 2 times x minus negative 2 times 8. So I'm using kind of a double parentheses because I have that minus minus there. All right, so negative 2 times x is negative 2x. All right, and then negative 2 times 8 is negative 16. But since I'm subtracting negative 16, that's the same as adding a positive. So I'm just going to change that right away to negative 2x plus 16. All right, number 5. So we have 5 times negative 3x. Smartboard getting a little slow on me. Plus 5 times 7y. All right. Now, when you multiply a number by a variable, you can simply multiply the number you're multiplying. So I can do 5 times the number in front of that variable. So I can do 5 times negative 3. That gives me negative 15x. And then I can add that to 5 times 7, which is 35y. That should be a 35. It looks like a 6. 35y. And we'll talk about more how that works in the next section. All right, last one. Got a fraction. Nothing about this changes just because it's a fraction. We're just going to rewrite by distributing that number to each term. So 1/3 times x and 1/3 minus 1/3 times 6. 1/3 times x is 1/3 x, and 1/3 times 6 is the same as 1/3 times 6 over 1, and that we can simplify by making that 2 and that 1, so that becomes minus 2. So there's our last answer, 1/3 x minus 2. All right, so for this last one, what we're going to do is we're going to use the distributive property to help us do a problem that would seem difficult to do in our head, and we're going to do it in our head anyways by using the distributive property. All right, so let's take a look. It says Mr. Ito needs to buy batting helmets for the baseball team. The helmets he plans to buy are $19.95 each. Find the total cost if Mr. Ito needs to buy 9 batting helmets for the team. So the way we're going to do this to make it easier for us is instead of saying each one costs $19.95, we're going to change $19.95 to $20 minus 5 cents, because that's the same thing. The helmets are the same. That's $19.95. $20 minus 5 cents is $19.95. And then we're going to use the distributive property to figure this whole thing out. So we need 9 helmets, right? So we're going to multiply 9 instead of by $19.95, because I can't do 9 times $19.95 in my head. We're going to multiply it by this 20 minus 0.05 or 5 cents. And watch how this actually becomes easier. So it's really 9 times 20 minus 9 times 0.05. All right, ready for this? Okay, so 9 times 20, well, I know 9 times 2 is 18, and I can add that 0 onto it, so that's 180, all right? And then I'm subtracting from that 9 times 0.05. Well, 9, that's like 5 cents. 9 times 5 is 45, so that would be 45 cents. So all I'm doing is taking $180 and subtracting 45 cents. Well, that's $179.55. And I just did that without the use of a calculator at all because of the distributive property. So you see how it's something that we can apply to numerical expressions as well as algebraic expressions to make some things a little bit easier for us. Okay, so that brings us down to our guided practice. So 1, 2, and 3, you're going to rewrite and evaluate each expression. So make sure you're showing me the term being multiplied, or the number being multiplied by each term in the parentheses. Number 4, we've got a little word problem. Use the distributive property. And then number 5, describe how the formula to find the perimeter of a rectangle is an application of the distributive property. So remember, the perimeter would be all the sides added up, or length plus width plus width. So think about that. We'll talk about it tomorrow.